is implicit differentiation. It's very interesting topic because we know that differentiation is a very important topic and a tool in calculus class. And first you start a differentiation topic by just learning the derivatives of simple functions. Then you learn the chain rule, how to find the derivative of the composition of two and more functions. But there also is a third part of the differentiation topic, which is implicit differentiation. And this topic is specifically dedicated to functions which are hidden in your equation implicitly. So your function y or f of x is not stated in your problem explicitly, which means, for instance, that you might have y equal e to the x squared plus 1. So you have this definition for your y function. So you know that y is equal e to the x squared plus 1. And there is no more y function on the right hand side. Everything here is expressed through x only, which is the argument of y function. So here, dear students, we have to understand that y depends on x. Y is not the independent variable, y is a dependent variable, and it depends on x, which is an independent variable. So if you have such form of the representation of y, we consider it to be an explicitly represented function y, because we have the definition for it. We have y equals e to the x squared plus 1. But if we look, for instance, at this equation right here, we have sine y plus cosine x equals 1. So here again, we understand that x is an independent variable. So everything is okay with x. But y is the dependent variable. It's our function. Y depends on x. So for instance, dear students, if we want somehow to get this explicit representation for y, how can we get it? So first of all, dear students, we can take like sine y equals 1 minus cosine x. So we can take this cosine and we can just move it to the right hand side. So we get rid of that cosine x in this left hand side. So now we are we have only sine y in our left hand side. But now y is still hidden under sine. So to be able to find y, we need to take the inverse to sine. So it will be arc sine, and then it will be taking of these both sides, left and right, because we have to apply the operation simultaneously to the right and to the left hand side. So our equation remains the same. And then here, if we take it, we will get here y, but here it will be arc sine of that, and it will be quite a complicated formula. So that kind of, I may say, algebraic manipulations or algebraic operations that you can apply for y will make your work to be very complicated. And also, dear students, yes, you take the y, but then arc sine, if you take it, it will go with a plus or minus sign. So you have to remember it. And that's kind of complicated. So in that case, when you are given this kind of equation with a function y hidden under sine, which means y is presented in this equation implicitly, to find the derivative with respect to the y function, as you get used to, for instance, if you have y equal cosine x, and now you want to find the derivative of it, which you denote by y prime, or sometimes you can just write dy over dx, which means that you are taking the derivative with respect to the x variable. And do you know what the derivative of the cosine x is? It will be minus sine x. Okay, dear students. So this is how we take the derivative of the function given to us explicitly. But now let's learn how to take the derivative of the function which is given to us implicitly. So we will be considering this equation, dear students. So I will delete this part, dear students. I will delete this part too. So let's see how we can find the derivative with respect to x of the function y hidden here. So we just do as we normally do. We just take the derivative of the left and the right hand side of this given equation. What does it mean? It means that we are taking the derivative with respect to x, because x is our independent variable, of the right and left hand side. The right hand side is very easy because you all know that the derivative of the constant function is 0. But now let's find the derivative of the left-hand side. So you know, first of all, that the derivative of the sum of two functions will equal to the sum of the derivatives of these functions. So we will have that it will equal to sine y, and here prime, plus cosine x, and here prime. So now, dear students, we have to take the derivative of each of these functions. First sine y and then cosine x. So first of all, dear students, here we have, and this is very important, this is exactly where the chain rule comes. We have here, dear students, sine as our outer null function, because sine is put, it's like outer function here. And the argument of sine is y. By y here is not a variable, dear students, and that is very important to understand. Y is not a variable, y is a function. So y, dear students, is a function which depends on x. So here, dear students, sine y is exactly the composition of two functions. It's the composition of this function sine with the function y. So we have here, dear students, to apply the chain rule to be able to find the derivative of the sine y. So let me just here below find the derivative by applying the chain rule of this term sine y. So by the chain rule, we have to do the following. First, we have to find the derivative of the outside function, which is in this case sine. So the derivative of sine is cosine, and this derivative has to be evaluated at its argument, which is y in this case. So we just write y. And now by the chain rule, we have to multiply it by the derivative of the inside function. And what is the inside function here? Here the inside function is y. So how to find the derivative of y? We do not know what the y is. Like, we do not know the explicit representation to y. Is it e to the x? Is it cosine x? Is it 2x plus 2? We do not know. We just know that we have y. So we just simply have to write multiplied by y prime. Sometimes you can write it as a dy over dx too, but I'll just write it as y prime just for a shortness of our notation. And now, dear students, we just continue. So we now have to add the derivative of the cosine x, which will be minus sine x. And in this case, it's easier term because there is no more y hidden here. There is no more function inside of function presented here. We just have cosine, our function, which depends on x, which is independent variable. So we just simply find the derivative of it. And then we just write it equal to 0, dear students, because this is our right-hand side. So let's see what we will get. We will get that cosine y multiplied by y prime minus sine x is equal to 0. So now, dear students, to find the first derivative, or the derivative of the first order of the function y, we just simply have to solve this equation that we obtained with respect to y prime. So we consider y prime to be our variable in this equation, and we just solve for it as we get used to do it in algebra. So we will get that y prime is equal sine x over cosine y. And that's it, dear students. This is what is our first derivative of the function y. Now, dear students, if you want to find the second derivative of this function y, we just have to find the derivative of the first derivative. So how then it will look like if you want to find the second derivative? If we want to find the second derivative of the y function, we just have to find the derivative of the first derivative, which means we just use this result that we got and we have to find the derivative of it. And here, dear students, you see, yes, you see that this is exactly the quotient rule because you have the division of two functions. You have the division of sine x by cosine y. So we will be applying just a quotient rule. So by the quotient rule, we have just to square the denominator, and now in the numerator, we will have the following expression. We have to find the derivative of the top function, which is cosine x, and now we have to multiply just simply by the bottom function, which is cosine y. And now we have to subtract, dear students, the derivative of the bottom function multiplied simply by the top function. So we are almost done, dear students. We just want to find the derivative of this cosine y. And this is exactly where this implicit differentiation comes again, because we again have cosine as our, or probably no, the chain rule. I'm so sorry, the chain rule. Because we have the cosine as our outer function and y here as our inner function. So we will get here cosine x multiplied by cosine y minus. And here we apply the chain rule, dear students. So the derivative of the cosine is minus sine. So we will get here plus sine y, and we have to multiply it by y prime, which is the derivative of the inside function. So this is the chain rule. And now we have to multiply it by sine x as the remaining term. And we are almost done, dear students, except of that we can substitute the value for y prime in this expression just using this result from the previous step. Because how do we want to find y double prime? We want to have here in the right hand side the expression that will depend only on x and y, and there will be no y prime or y double prime. There will be just y and x. So in that case, we will just substitute the expression for y prime. So we will get here cosine x times cosine y plus sine y multiplied by sine x over cosine y, sine x over cosine y, and then we multiplied it by sine x, and then we just divide this whole thing. We just divide this whole thing by cosine squared y. That's it, dear students. So this is exactly what the second derivative of the y function will be. It will be that big expression, that quotient, that fraction. So let me just summarize, dear students, what we considered today. Today we considered the explicit differentiation topic, And I showed you the example how to perform this implicit differentiation to be able to find the derivative of the function y, which is given to us implicitly. Thank you very much for your attention, and I will see you soon.